Good morning or good afternoon, CMS 8th graders. Today I'm going to walk you through an activity that we would normally do under different circumstances if we were at school. But we kind of felt that if we could show a little bit of what we're doing here, it might make a little more sense of where this new unit of looking for Pythagoras is going. So what you should have already have done is taken your lab sheet and written definitions for the three different types of triangles: acute, obtuse, and right triangle. And you should have read all of section 9.2.1. If you have not done both of these two things, hit the pause and read the section and write a definition for each of those types of triangles. Okay, now that you have a definition for the three triangles and you have a little bit of an idea of the activity that we would normally do in class, here is what they are really referring to in their explanation. So today what we're going to do is compare the side lengths of squares and see what kind of triangles they actually make. Do they make an obtuse, an acute, or a right triangle? So for example, if I were to give you a side length of 3, a side length of 5, and a side length of 7, what kind of triangle would that be? Would it be an acute, obtuse, or a right triangle? So as you look here are the definitions that you should now have: acute, obtuse, right. There's also three other types of triangles: scalene, isosceles, and equilateral. However, we are only going to focus on these three here today: the acute, obtuse, and right triangle. Acute triangle is where all angles are less than 90. Obtuse, where you have an angle greater than 90. And a right triangle is when you have a triangle that is 90 degrees. So here we go into today's activity. We are going to essentially build a triangle out of squares, but I'm going to focus on the length of the sides of each of those squares. So let's suppose that I have a side length of 6 and another side length of 12 and another side length of 13. Now if I put those three side lengths together, the question becomes, what kind of triangle is it? Acute, obtuse, or right? Now you already see that it's going to make an acute triangle, as I had to pre-type that in. But here's what we're going to do. So if we were in class, we would have taken a square that has a side length of 6 and a square of a side length of 12 and a square with a side length of 13. And we would put those together so that those three side lengths would make a triangle. Now if I do that, here's what the triangle would most likely look like. Get this out of here. Okay, so here we go. I'm going to draw this again. A side length of 6. Oh, let's redo that here. Side length of 6. A side length of 12 and a side length of 13. So there's my triangle, and I'll label those 6, 12, and 13. Pardon the drawing here, not as easy to draw on an iPad. Now if we think about this, if I were to make a square off of that side, the area of that square would be 144. The area off of this side would be 36 if I make a square, and the area off of this is 169. So up here in my diagram, you see that I have the length of the small side is 6. And if I make a square using that length, the area of that would be 36. The second side, the medium side, 12, gives me an area of a square of 144. So if I go in here and I write the area of the small square is 36, the area of the medium square is 144, and the area of the large square is 169. I'm going to scoot that down there. That's 169 again. Now if I add the area of the small and the medium square, that is 144 plus 36, which gives me 180. And so the small area plus the medium area is 180. Now how does this area over here plus this area compare to the area of the large square? It is obviously bigger. And if we go back and look at that triangle that was made by the segment 6, 12, and 13, you will notice that it is an acute triangle. A triangle that has all angles less than 90. Let's try another one here. Let me get the rest of this erased. So let's suppose I give you a square that has a side length of 8, another side length of 8, and the third side length of 12. And again, obviously I have it already written in there that it is going to be an obtuse triangle. So that side length is 8, 8, and 12. Now if I had given you the squares of each of those side lengths, I said, okay, here's a square of 8 side length and another square of 8 side length, and here's my 12. Put those together so that these three sides form a triangle. The triangle in black is the triangle you would end up with. So I'm going to draw those squares. I'm going to run out of room here. And we're going to do the same thing. The area of this square is 64, and that one is also 64, and the area of this one is 144. So I'm going to go up to my chart now and fill that in. The area of the square with the smallest leg is 64, which happens to be the same size as the medium. And so the area there is 64. The area of the large square is 144. Again, I apologize for the messiness on this, but it's not exactly easy to write using an iPad. So, if I add the area of the small square plus the area of the medium square, 64 plus 64, I get 128. 128 is what compared to the area of the large square? It is less than. And if you notice, we end up with an obtuse triangle. So if we were in class today, what we would have would be a bunch of these different squares of different sizes and different side lengths, and you would be putting them together and going through this process and looking at the triangle that was formed with the three side lengths to determine, is it an acute, an obtuse, or a right triangle? And so now if we move to the next here, this is what you would end up with in class. A bunch of triangles with different side lengths, and you see they're highlighted in different colors. You would have been looking at side lengths of 6, 12, and 13, looking at that triangle. 8, 8, and 12, we just did. Another triangle was sides 3, 4, and 5, and so on. And you would have put them together and filled out this chart and then looked at the type of triangle. And notice that they are all color-coded in terms of the type of triangle. So what I would like you to do right now is hit the pause, and I want you going back to your lab sheet and write down 3 or 4 observations that you notice in this chart. Please make sure they are written in complete sentences. Okay, so now that you have made some observations on what kind of triangles are created by the different side lengths, let's take a look at what we should have for sentences. If you noticed, the small area plus the medium area, when that area added up to be greater than the large square, the area of the large square, the triangle was always acute. If the small area plus the medium area was less than the area of this large square, then the triangle is an obtuse triangle, meaning an angle is going to be greater than 90 degrees. And if the small area plus the medium area equal the large area, the triangle is a right triangle. Lastly, there was a fourth situation that didn't even make a triangle. And that's when the small side length plus the medium side length was either equal or less than the large side. So for example, if I have a side length of 3 and a side length of 7 and a side length of 12, these guys won't ever even make a triangle. And if you think about it, here's why. Here is a side length of 12, and if that one is 7 and this one is only 3, will these two short sides ever touch to connect to make a triangle? They're too short. They need to be at least more than 12 centimeters long. So these are the 4 sentences that you should always remember as we move forward in this unit. Let's see what we have here. The area of the small plus the area of the medium is less than the area of the large. That means my triangle. So what does all this mean? How can we use these 4 statements? Well, here's 3 quick examples. If I have a side length of 6, 8, and 3, what kind of triangle is it? Well, let's see here. Here's a side length of 6, that was a side length of 3, a side length of 6, and a side length of 8. Well, if we go back and we look, the small area of the small side is 9, the area of the medium side is 36, and the area of the large side is 64. So, if I go fill my chart in, 9, 36, and 64. What is 36 plus 9? 45. How does that compare to the area of the large side? It is bigger. So these 2 areas right here add up to be, not bigger, but less than the area of the large. If I go back, is going to be obtuse. Next one. Going to erase this out of here, maybe. Okay. So here we go. Side length of 4. Side length of 7. And a side length of 5. Let's look at the areas here. 16. This is my medium side. 25. And the big side is 49. So if I go fill in my chart, the area of the small side, 16. Area of the medium, 25. Area of large, 49. 25 plus 16 equals 41. Which is less than 49. What kind of triangle is it? Well, if the area of the small side and the area of the medium is, sorry, that's not the medium. The area of the medium is less than the area of the large, it is going to be obtuse. Lastly, this last triangle here, if I take a look, I realize something about this triangle. The side lengths of 4 and 6 is less than 11. Think about what kind of triangle that would make. This one is not a triangle. So what you're going to do now is to use this chart and those 4 sentences to complete problem 9.54. When you're done, please make sure that you go and check the answers.